All right, so let's talk about function arithmetic quickly. I promise this is not actually hard in any way, shape, or form. The only thing that gets hard here is the kind of gobbledygook of symbols. So basically, I just need to tell you how to add two functions f and g. Okay? So when you add two functions f and g, there's only one reasonable way to define this. The reasonable way is to tell you how it does stuff to inputs, right? So the way this is going to do stuff to inputs is you're going to do f to the input, you're going to do g to the input, and you're going to what? Add the answers together. Cool? Notice something about the domains here. If I'm going to plug a number x in here, what do I have to know about it?
You can also go at the same time.
Yeah, it's got to be able to go into both the functions. So the domain of this thing, so the domain of f plus g is the domain of f. And how do I stick that together with the domain of g? No. No. Yeah, I need to staple these together. It's got to be in, right, intersecting. Because I'm saying that for something to be in the domain of f and g, right, of f plus g, it needs to be in the domain of f and also be in the domain of g. Okay, see how that's different than a union?
It's not with it, it's...
Yeah, so if I had two graphs and smash the graphs down, right, it's the area that gets smeared with both graphs. Yeah. You guys see that? You want a drawing of that?
Yeah. I'm sorry, are you whistling Christmas carols?
Christmas songs or that?
Okay, stop it.
Yes.
Okay, so say here's one of my functions. Knock it off.
It's addicting now.
Stop it.
It's not me.
Okay, so if I have these two functions, right? If I smash this way, which things are missed with both of them?
Both of them?
There's three of them.
Yeah, there's two functions here.
There's three.
So you create one smash though?
One is the swoops, I mean that one.
That's asymptotically awful.
Okay, so yeah, there's exactly two problems going on, right? The red one's got an asymptote, and the black one's got a hole in it.
Okay.
That's so cool.
You guys see that? So if I smash this way, right, everything gets covered by one function or the other, right? But the domain is really just everything except
For where there's
whatever value there's the asymptote, because that value doesn't fit into the red function, and whatever value there's the hole at, because that one doesn't fit in the black function.
So it has to fit into both exactly, not
Yeah.
having one covered only.
Yeah, exactly. Because if you know what this number is, and this number doesn't make any damn sense, then what do you add to that one? You guys see that? Cool. So if part of it doesn't make any sense, none of it makes any sense. Cool. Check.
See, so if you had 12 parabolas, each one would go over 1 point.
Parabolas domains are R, so they'd be fine. But yeah, this goes in general if you're adding more than one function together, right? The domains will be only the stuff that fits into all of them. Let's see, other symbols I have to give you. How does f minus g work?
You take the output of f minus the output of g.
Yeah, in exactly the reasonable way. You do f to x and then subtract g done to x. What's the domain on this one? Yeah, exactly the same thing, right? It's got to fit into both of them. How about if you do f times g?
Multiply the outputs.
Good. You calculate both outputs, f of x and g of x, and then you multiply them together. How about the domain on this one?
Same.
It's also the same thing, right? Okay. And the last one, which is the only tricky one,
The same with a twist.
F to the G?
f divided by g.
If G has an output of 0, you can't do that kind of input.
Okay, so if I'm doing f divided by g to a value x, right? I should do f to x and divide by g of x. God damn, what is with the markers today?
Don't put it
Or
back.
because I'm just a.
Okay,
And then he's gonna just.
what's the domain?
change it to this.
Oh, fine with me.
Same as last, except also not zero.
Yeah, so the domain of f intersected with the domain of g.
So G can't be 0.
Yeah, take away the values, right, x's with g of x equals 0. Right, so it's whatever fits in the top and fits in the bottom that doesn't also make the bottom 0. You guys cool? You could do similar rules if you wanted to raise f to the power of g or something.
It's the same thing.
And you would similarly need to restrict away from getting 0 to the 0 power.
If we had more than one function, it would just be just more of that.
Yeah, and if you have more than one function, then you think about one piece of it first, right? You just do order of operations like usual. Think about the pieces as you go. Cool? All right. Do you guys want an example for how to
Yes.
calculate some of these? Okay. Let me